Analog building block operational voltage amplifier in this op-amp. V input, V in, V out, V input plus V that is V input positive, V input negative. VD in, VCM, VDN equal to V input positive, VN, that is positive VN. Here VCM equal to V input positive, VN negative divided by 2. Okay. Then see here single-ended case study. In this single-ended case study, V out equal to GVDN GCM VCM, that is GVDN plus GCM into VCM, but GCM 0, that is V out here, this one. Okay. So VDN G is the infinity, and then GCM 0, VCM here this value, V input divided by VN divided by 2. This value we will get from here. Okay. Analog signal processing functions. Non-linear temperature uncompensated. Non-linear temperature uncompensated. V in plus minus wanted performance, negative feedback. Okay. Analog signal processing functions, non-linear temperature uncompensated, etc. V out divided by V in, V out divided by V in equal to G is here, and then divided by 1 plus GH, approximately 1 by H. This is as far as op-amp gain and bandwidth are large enough. As far as operational amplifier gain and bandwidth are large enough. Instrumentation amplifier. This instrumentation amplifier, one op-amp, second op-amp, third op-amp. From this here resistance R1, R2, R3, R4. Here also R1, R2, R3, R4 connected out. Here this output connected, then this input also connected. Here R1, R2, R3, R4. Okay. Here V in, one op-amp, second op-amp, third op-amp. Here connected first op-amp negative connected to this resistance. Second op-amp negative connected to this resistance, and then here in between this V in, and then this output connected to resistance. Here also this op-amp connected to input resistance, positive, negative also connected. Then this is the output. Here V out equal to V in, output divided by input voltage. Output voltage divided by input voltage equal to 1 plus 2R2 means 1 2 times R2, that's right, 1 R1, and then divided, then add with 1, then multiply with R4 divided by R3. Okay. And then here example IV converter. IV converter means current to voltage converter. Here in this op-amp, here grounded is positive. In this negative, we I in input. Here resistance connected in between this negative and V out. Resistance are connected. So here IV converter. It means so input input current in current only, output voltage. So output voltage divided by input current. Then we will get R. This is IV converter, current to voltage converter. Universal analog building block, operational voltage amplifier upon analog signal processing functions. This is non-linear, temperature uncompensated, wanted performance. This catch is connected V out and the input of the negative input of the op-amp. This is the V in positive. Here V out divided by V in equal to G by 1 plus GH. This catch here. So approximately 1 by H. As far as op-amp gain and bandwidth are large enough, gain and bandwidth are large enough, okay, in this op-amp operational. CMOS op-amp known as operational transconductance amplifier. CMOS amplifier is known as CMOS operational amplifier known as operational transconductance amplifier. That is OTA. O for operational, T for transconductance, A for amplifier. Okay. Then here VD in VD in positive, VD in negative, V out. Here actually here CMOS op-amp known as operational transconductance amplifier. Okay, this one CMOS. Okay, this op-amp is CMOS. Then GMRP not equal to infinity. That is here, that is this circuit here, equivalent circuit, that is here GM VDM not equal to infinity. This operational amplifier constant, this equal circuit, from here this circuit. Okay. So GM VDM not equal to infinity, R out, I out, V out. Okay, equal R out, V out, R out, V out, source GVD, GM RP not equal to infinity, GV DM. Here VDN plus minus IOut. Okay. Operation amplifier or OTA depending on Z load nature. Operation amplifier or OTA. OTA operational transconductance amplifier. Depending on Z load nature, switched capacitor, SC filters, VN, switched capacitor, SC filters, switched capacitor, VN, Vout, VN, Vout. Here it is plus connection, switch is the negative. Here also the negative side, here plus connection, switches is there. So they are like when it is closed, then to be also closed, then output. And when this switch closed, that a capacitor. Here also, when this switch is closed, capacitor through switched capacitor through, then here will not, then out. Otherwise, you will go to switch wise. Operation amplifier performance parameters: large scale, large signal static, figures ideal. Large signal static, figures ideal. Input range, output range, equivalent input offset. Open loop differential DC gate. IR tends to 0, OR tends to VDD, V of 0, GDC infinity. That is open loop differential DC gate. Infinity, G of DC. Equivalent input offset, output range, input range. Here differential input, so VDN divided by 2 in this operation amplifier, positive. In negative, VDN divided by 2, both are connected in parallel. Here connected in positive, negative according to this variable one. So here VCM both parallelly connected, common mode input. Common mode input, we can say common mode input. Then VCM connected to both of these input of the VDN divided by 2, that is half of connected through differential input. Then Vout. Open loop differential DC voltage transfer curve at a constant CM. Open loop differential DC voltage transfer curve, VTC. V for voltage, T for transfer, C for curve at a constant CM. In systematic mismatching, VDD equal to supply voltage, V of equal to V of bar plus or minus del of V of. This is V bar. Here this is VDAN, here plus VDD, here minus VDD, 0 V of.